All right, so today we're going to wrap up. So our first task is going to be to check in with Dora. Questions that you had for her several weeks ago, I guess now, about reading and writing strategies. We have plenty of time. Thank you, Jessica. That looks better. We have some time to kind of go. We have time for conversations today, and I doubt that our class is going to take an hour and a half. But so we want to do check in with Dora. We want to revisit your scientific explanation from last week, and we have a rubric we can use to evaluate it. And then we'll take a quick look at the fourth video of the river ecology teaching case, and have a chance. We'll put Adrian on the science better than anybody here, and have a chance to kind of talk about the science a little bit. And then we'll do a little bit of evaluation, see what you guys thought of this workshop in this format, and that's about it for today. And we'll be in touch. We are gonna, if you paid your $35 for this workshop, we'll be sending it back to you. And we want to thank you very much for helping us pilot this project. So do we have slides? Okay, next. Yeah, you can. Oh, that's my phone number. Harold is in is one of the little floaty boxes down there. So if you have any trouble, just get a hold of Harold, or you can call me and we'll put you in touch. So that's a good contact number. Oh, welcome, Tanya. We missed you today. So for everybody else, Toby was with us. So Toby's actually in the museum today. We've just been doing 2 days of professional development on the Nature's Fury exhibit, and working with Dora helped us with literacy strategies, and we did a lot of work. We also did some work with scientific nations there, so it was fun. So we're a little tired, but so today, if we have time, we'll take a quick look. We'll circle back at the NGSS practices. We haven't touched on those for a couple of weeks, but we'll take a quick look at that. We're going to check back in with our reading informational text. We're going to check back in with our scientific explanation about food webs, and that's mainly it on the workshop objectives today. Okay, next slide. We already talked about that, so next slide. Okay, so I'm gonna step off the stage, and next slide after this has some of the questions that you guys left in the survey after the second workshop regarding the literacy strategies. So I'm going to let Dora sort of address those, but we can also have a bit of a conversation. So if you have questions for her regarding using Common Core literacy type strategies to teach science. So remember, our goal here is, if we're going to teach science and we're going to give them stuff to read, we have to make sure that they can actually read it. And some of the kids in that. So we've been working hard to try to figure out ways to support science teachers in doing that. So I will step off and let Dora step on, and flip the next slide as you're doing that, Ray. All right.
Hi, everyone. Hope you can hear me okay. If you can't, please raise your hand or shout out. So you guys had asked some questions after I had a chance to present some literacy strategies to you, and I just wanted to answer some of those questions for you today. Question one of them was, can this strategy be used with science content such as textbooks in addition to these case study text passages? And the answer, in my opinion, is absolutely yes. If you're using a handout, obviously students can write directly on the handout. However, often you're using textbooks that don't belong to the students, and so you would want to use something like Post-its. Post-its come in all different sizes, and you can get really small ones, or you can get larger ones that you could attach in the margin of a textbook and refer back to them later. They also, one thing I do with reading aloud on a document camera, you can use those old transparencies and use wet erase markers to actually write on the transparencies, and I know that's sometimes useful. So hopefully that answers that question. The second question was, how often do you think this type of strategy can be employed? All of the time. And my answer to that one would be, I think you want to be very intentional about which strategy you're using and when. So I wouldn't necessarily say every text requires paraphrasing as a strategy, or every text requires, I think it depends on what your learning objective is. If you're reading text for background information and you just want someone to get a general sense of information about phenomena, then yes, I would use that kind of just main idea strategy in the margins. If you already have an investigation question and you have a particular focus question, then you might do more of a coding strategy to use as a lens for reading, where you're kind of ignoring paragraphs that have nothing to do with the relevant information, in which case main idea of every single paragraph would not be a useful strategy. So I would say it depends on what your learning objectives are, whether or not the strategy that I modeled for you would be appropriate. The next question was, how much time should be spent on having students extract main ideas in the classroom? And then the person wrote, this, class times a period about 45 minutes. So I would say that when at the beginning of the school year, when you're first introducing a particular strategy, the introduction and the teaching of a strategy can take a full class period, and application, modeling it. And if you've already introduced it, I don't think an entire science class any day should just be entirely reading. I think every class should be a combination of maybe a little bit of reading for context, or some type of working with models or an investigation work, and then revisiting text and so on. And so I think once you've introduced a strategy for the first time, you're just applying that strategy and reading. And I don't think would not say that 45 minutes of class should be spent on just main ideas of paragraphs. I don't think that is the appropriate amount of time. But again, it depends on where you are in the school year. And it depends on if you're just introducing a strategy for the first time versus applying the strategy to get information and make meaning out of text. The next question was, in which part of the lesson might be best to incorporate this? Meaning when during the class period. Again, I think it's similar to the previous question in that it depends on if you're just introducing the strategy for the very first time to your students during the school year, at the beginning of the year, or if we're just applying the strategy to help us understand an investigation that we've done or make sense of a model that we've developed or something like that. So again, I think it's really hard to answer that question without the context of the lesson. I would say during the beginning of the school year, you could have it be a whole lesson, but then once you're applying that strategy, you wouldn't even be modeling how to do the strategy at that point. You would just say to the kids, remember those menu of strategies, pick the one that works for you to get the most important information from the text to help answer this investigation question or whatever. So that one's kind of a tough one to answer. It absolutely is a strategy that can be used when students are reading text for homework assignments, so that when they come in with their text the following day, you can see their annotations in the margin as evidence of making sense of reading. Homework is a good opportunity for that as well. And the last question is something about having students analyzing and discussing the images. I think the key idea, I was trying to sort of model that for you when I was working with the river ecology text way back, was that you want, when the text relates to an image, you do want to bring their attention to the graphic, whatever that is, whether it's a map or a food web or a table. And you do want to explicitly identify, like, this text is referring to this image. Let's visit that image now and connect it back to what we were reading in the text. Not sure if that answers the question. If that was someone's question, please raise your hand, and I'm happy to help clarify that, because I don't know if I really answered it. So those were your questions. I'm going to answer more questions if you have them. Again, this is an opportunity for you to click the raise your hand button, and I'm available now to answer any other questions about the literacy stuff that I showed you, as well as some of the other stuff Dave might have done with you since then. That's it for now, unless anyone has questions. No questions. Okay, well, in that case, I can turn it back over to Dave. Dave, do you want to take me off the stage? Put someone here.
All right. Thank you very much, Dora. Thank you. So what we're going to do now, and if you have literacy questions, I don't know if Dora's going to stick around. She might be able to stick around for a few minutes and kind of take a look, and if they pop up as we're working this. So I don't know if you guys had a chance to print out. There was a rubric that I left that I emailed you, and it was also in the Moodle site. We can toggle back and forth between that and our scientific explanation too. But I want to take a few minutes and apply a rubric that we have. It's a general rubric for the designing a scientific explanation tool that we played with a couple times ago. And well, the last two sessions actually, because we did the example on chemistry and then we did the ecology data. So let's take a look at the next slide. So here's our model, remember. So we had this model, and we were trying to figure out at what point in this food web which niche in the food web would the zebra mussel occupy? And last time we talked a little bit about the fact that it would probably occupy a very similar niche to the clams. So we have the two clams there, the native clams. I can't read their names, but they're kind of located after the copepods. They probably eat more of the little stuff than is shown in this food web, since they're filter feeders. So basically anything that's small enough for them to filter will be consumed by them. So there's a potential then, if there's a huge amount of zebra mussels, that they'll have a huge impact on the environment. So you guys looked at the data and came up with your own answer to the question about the impact of the zebra mussel on a specific population. I think you picked the rotifer. And so, and of course, your food web doesn't show the rotifer being eaten by the but if it's small and floaty, it's going to get consumed by that. So next slide. So here was the data that you looked at. So this is basically the graph of the zebra mussel population in two different forms. So you have a line graph that shows the trend over a long period of time. The orange is the zebra mussel. The blue is our rotifers, which is what you chose. And then the two bar graphs. I'm sort of going over this for people who may not have been with us consistently over the last couple weeks. But so the blue is the rotifers in the early stage. I think it's until 1993. And then the zebra mussels were barely starting to become established. And then you have a huge decline in the rotifer population and a huge increase in the zebra mussel population. So let's see what you did with that data in your scientific explanation. So I can't read this. I don't have a full screen button. Oh wait, I do. Okay, never mind. All right, just learning the technology. All right, here's what you guys came up with for your. Maybe it'd be better. Sorry, I didn't. I wonder if Pete would mind popping up on the stage and kind of walking us through what you guys were thinking here, since you were involved in that, in creating that. Is that something you would do, Pete? Yes? No? Okay, he's sort of smiling. Why don't we trade places and put Pete up, and he can kind of take us through. Yeah, good. Take us through what they were thinking and how they constructed their scientific explanation last week.
Hi. So I'm just gonna try and remember what we did because I don't quite remember. But okay. So we let me get this up. We ended up making our claim that I wish I had all these things up. We ended up making a claim that zebra mussels negatively affect the population of rotifers just because because they were smaller and because we hypothesized that clams and zebra mussels had a similar niche. And let's see, our evidence that we had two pieces of evidence. So once we made our claim, we found a couple of pieces of evidence that supported it. And based on the data that we looked at in 1993, when which is when zebra mussels were known to be introduced, we saw a similar decrease in the rotifer population as the rate of zebra mussels increased. So as the rotifer population decreased, then zebra mussels increased. So we saw that relationship was there, and we thought it supported our claim. And in 2002, also in the data, the zebra mussels dropped, their population dropped, and we saw a rotifer kind of spike, which also supports our claim that zebra mussels negatively affect it. And yeah, so that's about it. I think we kind of, so based on our evidence, we kind of used the predator-prey relationship, and we figured that based on the data, zebra mussels were the predators of rotifers. And I think that's it. I guess you can take it.
All right, thank you very much, Pete. That was great. So what we're going to do now is, so the next step of this process was to actually put all that together in a paragraph. That's, I think, the next slide. Yep, so there we go. So the scientific explanation includes all three of those things. So basically, I'll give you guys, you might want to full screen it. I can't see it if I don't full screen it. So you might want to put this on full screen. I'll give you a minute to read through it. And then we're going to have to toggle back and forth with the rubric, and we'll look at specific elements of this compared to the rubric. So take a quick read through, if you will. Okay, so I'm going to go to the next slide. All right, so we'll do a little toggling back and forth. So here's let's look at the first level for the claim. So we have this broken up between and proficient levels. And so the proficient level, the claim answers the question, is accurate and is complete. It completely describes the trend in the relationship between, we don't really have an independent and dependent variable here. We sort of do. I mean, we have the zebra mussel compared to another thing, but I wouldn't. Time would be the independent, and so the population of of both of the populations would be dependent. But we're trying to figure out if there's a relationship between the zebra mussels and the rotifers. And your claim, so I guess, does the claim do that? Does it completely describe the trend? Or if you look at dancing, does it answer the question and is accurate, but it's incomplete? So let's toggle back to the explanation. So basically, my claim is that zebra mussels negatively affect the population of rotifers in the Hudson River ecosystem because in 1973, when the zebra mussels were introduced, the population of rotifers decreased. So you're actually partly getting into the evidence there. But so the claim is that it would negatively affect So what do you guys think? Somebody want to pop up here and talk about whether how they feel that claim is addressed? Yeah, just raise your hand and Ray will pop you up here. Just put them up, like, can you put them up in the screen share, or well, you have to trade? Okay. Janice, or nobody's raising their hand? Oh, Toby is, right? How do you think the rubric applies to your claim, Toby?
Well, I don't have it in front of me now, but I would have given it a 3, that it is accurate but not complete, because it specifies those 2 years. There's a big gap between those 2 years where I don't have the years in front of me. One is 2002, and what was the other one?
1993.
1993.
Yeah.
It doesn't account for all that time in between. So to me, and I wasn't here last week for that discussion, but I think it's supported with evidence. Cause and effect can be established, but I don't know if it would be sufficient to be a completely proficient, where it would get a 4 on that rubric, because there is so many years that are not accounted for.
Okay. Put the slide back up. Okay. Anybody want to other thoughts? Yeah. I think it's better if we just do one at a time and keep this slide. So trade places with me, okay, Ray? So we can keep referring to the slide.
Hi everyone. I think I agree with Toby, but her comments apply more to the evidence than to the claim. If the claim is, it's the population was affected by the zebra mussel, and then we have the evidence that we get from the data. And Toby is right. Maybe we could have added more data regarding the years between 1993, more details, and that would have made the evidence more, sufficient. But
Not at the other.
yeah, so we'll check what happens with the evidence.
All right. So one of the things that the rubric mentioned was the idea that so can you flip to the rubric? Other way. Oops. Oh, forgot about this. Yeah. So one of the things that the rubric mentions is the claim answers the question is accurate and complete, and I think there is a for both of those, advancing and proficient, I think there is a clear relationship, and that the claim is accurate, that the zebra mussels negatively affect the rotifers. So, yeah, I mean, I guess there could be more elaboration on the claim, but I think it's pretty good, and I think that we're, at least a high fee, if not a 4 in there. So I agree with what. So let's take a look at the evidence. All right, and we've already looked at this rubric before with regards to our chemical data. And so now we're looking, we'll flip back to the explanation again. So let's see if it provides, I can't read it. Sorry, going too fast for me, sorry. See if it provides appropriate and sufficient evidence to support the claim. or if it provides appropriate and sufficient evidence to support the claim, but may include a little bit of inappropriate evidence. So let's see if we can judge it on that level. I'll give you a couple minutes. See if somebody wants to pop up and talk about what they think about that part. Anybody raising their hand? Yeah? Okay, put Tanya up. Switch.
Hi, can you hear me? When I looked at it, I looked at the graph, and I think one of the things I saw was the zebra mussel population kind of cyclically went up and down. And the evidence with the 2003, that when it dropped and the rotifer jumped back up, to me, I would say it would be about a 2 or 3 because that only happened once, but the zebra mussel population decreased a couple of other times, and that spike never happened. So I would say there's a level of maybe, I wouldn't say inaccurate, but maybe unexplained. That whole spike is unexplained because why didn't it happen the other year that the zebra mussels decreased?
All right. Jessica, did you want to talk? Saying yes or no? Okay. All right. So let's take a look at that. I think Tanya makes some really good points there. So there is a spike. Can you go back to the graph? Yeah. So there is a spike. There's a couple spikes actually, and a couple decreases, and it's a little unclear, if those are related. But there does seem, I think the conclusion that when the zebra mussel population went up, the rotifer population went down is really well supported. And it's interesting. Sometimes it's really hard to make direct, causational statements based on the graph, but there does seem to be something going on that second time that the zebra mussel population drops, that the rotifer population spikes up a little bit. It goes back down again as the zebra mussel population increases. So we're talking about a lot of data that wasn't in the initial explanation. Why don't we go back to the explanation? Just raise your hand. But what it says here, so it mentions the initial decrease, and it talks about the other little spike. And so I think, go to the rubric. I think that, in my opinion anyway, if I was the teacher, I would give a level 4 because they're providing appropriate evidence. So looking at the levels of the population, and they're even going beyond the initial decrease. So they're looking at evidence past that one decrease, which is probably enough to say there's a direct relationship. But they're also looking at the balance up and down of the population at different times and seeing if there's a relationship there, and it looks like there might be. So Adriana wants to talk. Yeah.
I agree with Dave. It's a very good set of evidence. But one that actually you could add to make the evidence sufficient is you can add numbers. So you can see how the mean, the annual mean of Waterford, which actually before 1993 was above 1K, after 1993, it's always below 1K. And the different peaks that you are mentioning, remember that there's a seasonal change underneath the reduction. And we always talk about the average. And of course, there are things that actually scientists will say we can't explain. But we will see later what happens after 2005. And that will be really striking to see.
So Jessica has her hand up, so we're going to put her up on the stage for a second here.
So I wanted to ask, as if you're evaluating the claim written by a student, if you would be strict about whether or not the student was included within that paragraph.
I'm going to put the slides back up too. So Jessica's question was, as a teacher, would you be strict about having them include quantitative evidence? And I guess I would say yes. And as I was listening to Adriana talk, I sort of was thinking about revising my opinion. If there are numbers, data, then the numbers should be included in the scientific explanation. That's part of the sufficient. So sufficient in the way we've sort of kicked it around here is that all the evidence that you have that fits and can be used to explain that phenomena should be included. And so the fact that there's numbers on the graph, and go back to the explanation, Ray. Next one, yeah. So I mean, they do mention the rotifer population briefly recovered to a population of about 850, but there's more numbers that could have been mentioned. So, you know, I would say this is like maybe a low 4 as far as that goes. So let's look at the reasoning. So go back to the rubric, please. Next slide. Yeah. So the reasoning here is really broken up into two different buckets. Hold on. So we have the bottom one is logic, and the top one is the science concept. So whether they're getting the science concepts right. So let's take a look, and you know, I'm sort of going to the level 3 and 4. So the high level includes explanation of science concepts that link evidence to the claim. Concepts are appropriate, so using the concepts correctly, and they are sufficient. So there's no omission of key science concepts, and they're clearly stated and accurate. And then the level below that includes explanation of some science concepts that link evidence to the claim, but are insufficient. So they're not including everything that really works for that explanation. So maybe one or more have been included or that should have been included or not. So let's take a look and see if we can apply this to the explanation that we had. So basically, based on our evidence, we can hypothesize. So you're sort of explaining, not hypothesizing anymore. So maybe I would have chosen a different word, but that's okay. We can hypothesize that the zebra mussels are eating the rotifer and that they have a predator-prey relationship. We also know that the zebra mussels are filter feeders. So you're bringing in knowledge about the zebra mussels, and you're explaining that the rotifers are small and plankton-like and would likely be eaten by the rotifers. So I think that's including quite a bit of the science. How would you guys, I'm going to step off the stage and see if anybody wants to pop up and see what they think and how they would apply the rubric to this explanation. Anybody? Somebody raising their hand? Somebody's raising their hand? What do you think, Adriana? Well, it's Pete's explanation. Hey, Pete, why don't you grade yourself? Hate to put you on the spot, but we're going to.
I give myself a 4 for everything. No, okay, so let's see. Looking at concepts, we used one concept. We specifically said a predator-prey relationship. So, and we said based on our evidence there, which we already stated, we believe that it's a predator-prey relationship. So, I guess that is clearly stated, accurate. So if there's a predator-prey relationship because of the data, then it inevitably affects it. So I guess I would say reasoning would be a 4. I'm sorry, concepts would be a 4, and then logic. Yeah, I think that there's a. I think the reasoning is probably one of the ones that we probably did the best. Just we connected. This explains why rotifer population dropped so steeply. I think it connects all 3 parts together. So I guess I would give both.
Next one. Yeah, there we go. So yeah, I think Adriana and I were sort of agreeing here with you. And I think that the explanation of the science concepts is good. So you had the predator-prey relationships, and you linked that logically to why the populations would change. And so we're agreeing that that it is before. So both Jessica and Toby have their hands raised. So let's go with Jessica first, and then Toby. Oh, just Toby? Okay, just Toby has her hand up. So I'll step down and put Toby up.
Not that I want to say that it's not a 4, but is the predator-prey relationship really established in that statement? If you go back to the statement, because it still seems like there's a little bit of an implicit assumption that a predator-prey relationship, for example, there could be some other factor. You know, perhaps the chemistry of the water was affected, or, you know, there could be some sort of byproduct. I still feel like there's a little bit of an assumption about the predator-prey relationship. But then again, I wasn't here last week, so I don't know. I might be missing something, or it might just be the way that's worded. I mean, obviously it makes a lot of sense, but if you're, to me, if you're looking to establish a 4, it doesn't seem 100% to me, and I don't mean, you know, not trying to criticize it. I'm just trying to establish, like, you know, how much is that still an assumption, or is that actually that sentence where it says, based on our evidence, we can hypothesize that the zebra mussels are eating the rotifer and have a predator-prey relationship. I guess that's the thing that I'm wondering about.
Okay, so just to respond to that, I think that's why we wrote hypothesize instead of we can definitely base, we can definitely say that it's a predator-prey relationship. I think we hypothesized that it was a predator-prey relationship because we were looking at the model, which we kind of established that the zebra mussels would take the niche of the clams, which eat rotifers, and we also just hypothesized it because of just how the data was. So I don't think. So I think that's why the word hypothesize is there, and I think that's why you know, yeah, that's basically all I was gonna say. Good.
I agree with Pete, but at the same time, now that I'm thinking, another possibility, and this could be it could be the same. It could be there's another explanation, and it's similar to the explanation to the reduction of the population of the fish that eat plankton. Maybe the zebra mussel doesn't eat rotifers, but they eat the food of the rotifers. So the zebra mussel eats so much phytoplankton that the rotifers didn't have food. But that's at the same time we about that the way of checking this explanation is by looking at what the zebra mussel ate. So just opening the zebra mussel and finding out if they ate phytoplankton or rotifers. And I think that we said that they ate rotifers. But to say we hypothesize, it's a way of immunizing your explanation. So that's good. Right? No, still.
Okay, I stand corrected. I think after hearing Pete and Adriana kind of mull that over, I think that I would agree that hypothesize does fit there, and I think think about if a student wrote this explanation. I mean, they would based on this explanation, you would definitely be seeing that they were understanding what was in the food web and where we had placed the clams. We would assume we would have already had the discussion about whether the clams and the zebra mussels would occupy the same niche. So I think to hypothesize that there's a predator-prey relationship, I think is actually the appropriate language here. I think that's really good. But Adriana does raise another concern. It's like, do we know that's exactly what's happening? And we would need other kinds of evidence in order to firmly establish that. But I think that evidence does exist. So I think to say that there's a relationship, predator accurate, and so I really like this part of the explanation. Okay, so Jessica has her hand up, and so we're going to pop her up on stage.
Well, I had just wanted to ask, since I was out last week, if we were given information as to whether or not those zebra mussels that they consumed. Oh, so Adriana basically read my mind. So yes, so
So Jessica's question, because I'm going to repeat it, Jessica, because you were very crackly, was what since she wasn't here, were we given information about where the mussels ate, and not directly, but we did talk about. We looked at our food web again, and we talked about where the zebra mussels might fit, and we kind of sort of came to the conclusion that they would fit where the native clams and mussels are. And of course, one of the things that they eat is the rotifers. And so we have that indirect evidence. We could probably look for a different source. As Adriana says, we would probably need to look at some of the studies that actually look inside, do a dissection of the zebra mussels and look at their stomach contents. And we would most likely find that they eat rotifers. So, I think this is good. Any other questions about this? Yes, no? All right, let's move forward then. So just to wrap this up. So the scientific experiment tools, this DSET, you guys. So we gave you the practice, with the chemicals. So I think that helped sort of separate out, what we expect as far as your claim and then your evidence and then your reasoning. With students, I think you really need to be very deliberate about how you're using the scaffold and really make sure through and working really deliberately with it. I don't know if Dora has more to say about using this with students. I never have. She has. So I don't know if she wants to comment. Does she have her headphones on? Is she listening to us? Okay, she's putting her headphones on. So why don't we bring Dora to the stage and she can comment on the DSET.
Yeah, give me 1 second, headphones on, and then I will comment on the DSET. Okay. So, okay, hopefully you guys can hear me okay now. Yes, good. I would say that the literacy strategies come into play most usefully, obviously, during the reasoning section. Specifically, paraphrasing can help students with the bringing in the most relevant science concepts into their own words, so that they're making those explicit connections. So I think, and then, yeah, I think for me the literacy strategies for the reasoning section are the most useful when trying to support students with making connections between their evidence and their claims. I think in lower grades, I, as a teacher, would provide that I would screen the text myself and provide explicitly students, like, here's the most useful text, and give it to them. In the upper grades, high school, I would, once they have their own investigation question around this and so on, and they needed more information, I would let them do more of their own independent looking for text and check it. So it depends on the level of your student. As for this isn't what you asked me to talk about, Dave, but you asked me to talk about the DSET, but just my own experiences working with this teaching case in the classroom with middle school students, comparing my first year using it with my second year. The first year I did it, I let all my students pick whatever variable they wanted to investigate compared to any other impact variable they wanted to look at. And the second year I did it, I had everybody look at the impact of zebra mussels on, and then I specifically assigned different groups, different deep variables, and that was so much more, I was much more successful in the second year. The student writing was much better when I strategically, when I looked at the graphs in advance, saw which ones were easier to write about than other ones, and so that I let students have some choice in which variables zebra mussel impact, but I was much more strategic in assigning particular dependent variables to my different groups. and that worked out much better the second time around. So that's one piece of advice that I would give. But I'm happy to answer other questions about my experiences using the teaching case with my kiddos. If you have any, otherwise I can turn it back over to you, Dave.
All right. Thanks, Dora. Thank you very much. Yeah, one of the things that we did last week, and it's in last week's PowerPoint, that I'll make sure, I can't remember if I even posted it in the Moodle, but I'll make sure it gets on the Moodle site. So we looked at, I made some slides of some of the variables that showed a clear relationship. So I remember chlorophyll was one, the rotifers was one. There was a relationship, I think, with one of the fish species, the alosa, so which is like the shad, that are kind of, they feed on, being filtered by the zebra mussels. And I think some of the other small crustaceans were affected as well. And so, you know, that was very purposeful because I wanted you guys to actually write your scientific explanation about something where there was an effect. And so, as Dora points out, if you're using this, especially with middle school kids, I think it would be really valuable to steer them in that direction. Otherwise, I think that the data can be kind of confusing, and there may be relationships in that, but it's just not fine-grained enough that you could really sort them out really well. Why don't you hop up on the stage and tell them? Yeah. Oh, okay. So yeah, Adriana's reminding me that we have more data. We have data beyond 2005 that we didn't include in the graphs that we showed you. And so I think now is really, it's a good time, unless there's any questions about the DSET. If you have any more questions about the explanation tool and the activity that we did in writing this explanation, raise your hand. But if not, we're going to queue up the fourth video, which sort of talks about what happened in the river, you know, past what we've been looking at data for. So we've sort of been looking at the impact of the zebra mussels right after they invaded. And so now we're going to shift and look at the last piece. The reading's available for you. We're not going to read it today. We'll just kind of watch the video and talk about it, 'cause I think it's clear enough. And look at what the folks from Cary are reporting for us after the initial invasion.
We are on the Hudson River at Port Ewan on the west side of the river, and we are collecting zebra mussels to monitor their population. Keeps bringing them, fully loaded. So here's a rock, and you can see that there are some older zebra mussels on it, these larger guys, which are a few years old. And then you can see all of these small ones that are attached on here. These all settled out last August. So what we've been noticing is a few years ago that they were mostly large, and then you saw a few small ones. And so now what we're seeing is that we don't see much survival between June and August of the large ones, and we'll see that there's more small ones covering. And so each year there appears to be more and more smaller ones.
We used to see 1.5-inch zebra mussels pretty regularly in the river, and now I don't think we even see 1-inch long zebra mussels. They don't get to be that big anymore. And that's interesting because what a zebra mussel eats depends on how big it is. So only the biggest zebra mussels can eat zooplankton. Zooplankton are relatively big for them. And so one of the other changes we've seen in the river is that the zooplankton populations are starting to come back.
The lifespan of the mussels has gotten much shorter. The logical follow-on question is, why have these changes occurred? And I think it's fair to say we really don't know at this point. There are a variety of sort of logical possibilities, but none have been, proven beyond a shadow of a doubt.
There are a couple responses to it. The first is, as scientists, this is cool. I mean, we're seeing something different happening in the ecosystem. And so that's a new problem for us to try to study and understand. What studies should we do? What do we do next? This is seeing the same thing over and over again isn't that interesting scientifically, but seeing something new and unexpected is interesting.
We're seeing that humans brought the zebra mussels in, the zebra mussels came in, and now there's recovery or there's balance coming back into the river possibly. If we did not monitor it long term, the story always would have been that the zebra mussels came in and there's no more zooplankton, that the zooplankton declined, and that's just the state of the river, which that's not the case.
We think it's always important to continue monitoring because the river is always changing. Some of those changes are natural and they're what we would call normal progressions, and some are not. So again, the more information you have, the more you can pinpoint what's causing the changes that you see in the river.
All right, so I think that's really interesting. So something seems to be happening in the ecosystem that I think we actually know a little bit more about now, since these guys have been continuing to study this and have published since the days when we recorded them for this video. So I'm actually going to trade places. Adriana's going to use my computer, and we'll share my screen, and she's going to talk you through a little bit about what some of the data looks like on the using the graphing tool. Okay, so back. Mm-hmm. Sharing. Oh. And you want to go right here. Okay. On the full screen.
So go full screen. So what we did, what we showed you for the exercise for the VSET was just a cut of this graph. We gave you only data. I mean, let me go to Spotify. So if you remember, the graph that you used for your explanation just went up to 2005. But since we first made these videos, they added more data. And you can see that after 2005, there's actually the mean for the population of tropicals is going above 1K. So, and if we do split, if we do the split of the years, so we see that the first set of columns before 1993, the rotifers were almost 1250. In the earlier years of the invasion, rotifers went below 50, and after 2005, there's a recovery. And the story is that it's in the video. I mean, the little zebra mussels can't eat rotifers because the rotifers are too big, but still they can eat phytoplankton. And that's also one of the reasons why phytoplankton hasn't recovered. But the other question was, if the zebra mussel is going up and down so dramatically every year, is there any predator? As any predator? And I don't know if you noticed that this top-down menu of variables doesn't include the blue crab. The blue crab that we included in our model of the food web. The story is that they found out that the blue crab that migrates along the river comes down by August, and after so by August, the population of the zebra mussels go down quite dramatically, and they made experiments to find out if they were really eating them. So the fishes haven't, the populations, there's not much evidence that are going up. But yes, the zooplankton and the clams a little bit went up also after 2005, but not as high as before 1993. But what they think is that we are going towards some sort of balance, but the final, or if there's any final, I mean, this is a process that can take decades, will take decades. And one of the reasons is that we are talking about things that live 1 year with things that live 30 years. So the life cycle of all these critters is different among species. And so I don't know if you followed when I split the screen, but you have to, in the first split date 1, you need to choose date of 1993. I chose February 28th. And the split 2, you need to select any day of 2005 to obtain these 3 columns. So still they are monitoring the river, and we'll see what happens. But I just wanted to note this before we keep going, is that this is probably the only institute that had data before the invasion of the zebra mussel. So that was so cool for them to be able to compare what was before with what was happening after that. So it was really, they were in a situation of privilege, in the sense that because of this monitoring of the river, they were able to really follow the whole process, and they are still monitoring. Because that.
Yeah, see if there's any questions.
So question, I can see them. So.
Questions about the science and case studies.
Yeah, I mean, if you have any question about the science or the use of the teaching case.
Come over here. No. Don't worry about it. I understand.
So definitely you can use the teaching case without the graph tool, and that's what many teachers do. But you have the cards with the pictures, so to make a model of the food web, and so you can add a card for the zebra mussel and change the food web, the model. We just talked about it, but you can literally add the picture of the zebra mussel. So the key thing here is that the zebra mussel size, and therefore changed the size of the food. So big zooplankton was able to recover. Not as much the naupli. That's why we included the naupli copepods in the model. The naupli are the babies of the copepods. So, and that's affected more because it's small.
Sounds like Jessica has a question, so we're going to pop her up.
This is probably another thing that came up last week, but is the raw data for all of this available for download?
Well, the graphing tool is loaded up through 2013, I think. So we have the graphing tool is all set. We do have some scientific papers written by the scientists at the Carey Institute, and what we'll do is we'll put those in the Moodle site, and so you can take a look at them.
Okay.
And so they describe a little bit what's going on with the blue crab and everything, and so the rebound of some of the larger animal species. So.
Okay, cool. But is the data available as, say, like an XLS file? I'm just curious, like, without having to use the graphing tool.
That's a good question. I don't. I'm looking at the graphing tool right now. That's why. And I'll have to check on that. I don't think it is. A lot of the data is available in the papers, but I don't know if there's a digital way to download it from the site. And I'll have to check on that, and we'll get back to you.
Okay, thank you.
The numbers. Oh, so Adriana's telling me you can download it as a Excel file. So good. That would make sense. So one thing that I just want to hit on, and this went back, 6 weeks ago when we first started along this road, is, one of the big purposes of the teaching case materials is to help your students to contextualize the data. So while you could do the story of the zebra mussels and kind of look at it, it really seeing video of divers going down to grab rocks that have the zebra mussels on it, and seeing the second video, where they showed how they worked in their lab and how they filtered the water, collect organisms, and how they were measuring the zebra mussels and everything. I think that really helps kids to understand that data set. So when they look at those graphs, they make a lot more sense to them. And so that was really our purpose of putting together these materials. And so there's multiple uses for it, but we really encourage you to explore these with your students and look at the data with your students. Yeah, Adriana is reminding that when we've done face-to-face professional development, these resources, the museum is 3 blocks away from the Hudson River, and so we've gone over to the river, and actually we have a Secchi disc, so we play with the Secchi disc and look at how far underneath the river it goes. We measure current. We have a plankton net. There's no zebra mussels down here by Manhattan because the water's too brackish for them here. So they're mostly up, I think, above Havistraw. But it's useful, I think, if you have an opportunity to get your kids close to the river, to actually have them at least model some of the ways that the scientists collect the data. So any questions about, I guess, about anything that we've done over the last 4 weeks? No? Pete? All right.
Hey, so I was basically thinking about the progression of kind of how I would make this into a, I guess, for students. And so basically I had something to the effect of the first part is just introducing the video, kind of having doing a little article that introduces invasive species and introduces zebra mussels, then the second part would be more like literacy strategies with the article, and then creating a food web and creating a model, and then that goes into basically using data to create a scientific explanation of that stuff. Is that kind of on it, or am I missing something? Or
Yeah, I think that's right on it. I mean, I think that the progression that we sort of took you through, I think would make a lot of sense. You might want to do it a little slower with your kids. Remember,
yeah,
we
for
showed you that the first video that dealt with, more generally with invasive species and mentioned the zebra mussels, but there's other stuff that would be great to have them read about invasive species. And I mean, there's invasive species everywhere. And how you define them, Adriana could probably be more clear about it, but invasive species are non-native species that somehow impact the environment. We have them if you look out your window, the house finches, or the house finches, what are they? The house sparrows, yeah, that nest everywhere in New York City practically. Those are invasive species. So they've in effect kind of taken over every niche that they can grab onto. They're really adaptable to urban environments. And, any native species that would have been here, there's not a lot that would, live in the city, but they've, they're here, and there's something you can see. Earthworms are an invasive species, believe it or not. So, there's a lot that you could have the kids look at and kind of investigate. Animal invasive species, there's also things that are plants that live in various environments, locally as well. So it's like invasive species are everywhere. We can't avoid them, and so, what this does is give you a nice opportunity to explore data that are involved in them. So I like what you were proposing, Pete, as far as a progression, through the material, and taking your time at the beginning to establish what the invasive species are, and getting some background on that. So it's really nice. Anybody else have any ideas?
I had one other question. Is that Moodle page going to be available for us for a while, or how, or will it?
Yeah. We'll just leave it up. We'll leave it up indefinitely, and I'll be available via email. If there's stuff that you would like to see on there, just let me know via email. But I've always BCC'd all you guys, so I mean, with your permission, I'll just send out an email to everybody with everybody's email on it, so we can just CC everybody that you guys would like to continue about this material. That would be cool. So what we'll do is I'll make sure all the slides are posted in the Moodle page. I'll make sure all the resources that we use there. We'll have links. I'm not sure how long the Shindig links will last, but we'll have links to to all the videos from all these sessions, and I'll work with Adriana to get some of the original papers by the Carey Institute posted up as well. And so we'll leave that for you indefinitely. And if you'd like to see that, anything put as a community. Any other questions? Anybody?
Okay, sounds good. Thanks.
Hey, Jenna.
Hi,
Well, there you are. I couldn't see your face before.
Yeah, I don't know why it wasn't working. So I have a question about potential field trips to the Hudson River. Granted that there's no zebra mussels that are visible from where our students would be able to go in Manhattan. I'm wondering like what other types of activities could be reasonable and involve like not a whole lot of introduction that I can do with ninth grade students if I were to plan a field trip.
So what we've done is plankton nets. So we actually purchased some plankton nets here, but you can make them pretty easily. If you link online to constructing your own plankton net, you can do that. We have a Secchi disc So we
Thank
take the
you
Secchi disc. So basically what we is to model as much of the data. So we look on the graphing tool, and so a lot of the data, we couldn't count any of the organisms, but any of the abiotic factors, if we could find a way to test it, we did. So we took water test kits. So we were looking at dissolved oxygen. That's pretty simple. Yeah, and Adriana reminds me that it doesn't have to be the Hudson River. It really could be any body of water. You could, have them go and just, use the techniques that they see in the video, just so they can get an idea, what those scientists did. So, once again, we're trying to contextualize this large set of data. So the videos are one step, but I agree with you. If you could get them out to a body of water, the Hudson would be cool. If there's a safe place you can go, but any pond would work as well. And just kind of have them practice on some of the techniques that you saw the using. And a simple like remote water test kit would allow them to test the pH and dissolved oxygen, things like that. And in a lot of places, especially, we haven't had a lot of luck getting the main things out of the Hudson ponds in Central Park. We find lots of, we have found rotifers there. We found other kinds of organisms if you pop it under a microscope. So, then the kids kind of are always pretty excited, especially middle school kids, of seeing these things, from their local water.
Okay, thank you.
Okay.
I just want to say for Jen who asked, our school, I work for one of the suspension sites that are in New York City. We actually got to go into the Bronx River. The Bronx River Alliance likes to partner with schools, and they did with our middle school in Queens, a bunch of the suspension schools in the Bronx, I think one in Manhattan. And then they took a bunch of the teachers, and we went in the Bronx River and pulled up zebra mussels. We pulled them into our classrooms, did a lot of the testing and stuff, like on the water, all that kind of stuff. So if you were looking to bring the kid, I would contact them. They have a whole program set up, and pretty much they're utilizing the schools to collect data for themselves. And it's a great way for the kids to go out there too and dig up and see the zebra mussels in there too. So that's an option. I mean, I can actually look up who our contact was and send it to you, Dave, if you want to send it out to everybody.
Yeah, that would be fantastic, actually. And we've actually taken teachers in some of our summer programs up and gone down the river in canoes with those guys, and they are fantastic. I didn't realize there was zebra mussels there, so if there are, that's a really great tool, and safety conscious too. So if you wanted to take a field trip with your kids, they do this all the time, and so rather than taking them and maybe losing them in the Hudson River, I'm just joking. But the Bronx River Alliance, they're really good at conducting a really good field trip, as Tanya can probably vouch, and so that might be worth looking into. Okay. Any other questions? All right, so we sort of reached, I thought we might finish early, but discussion. So we reached the end of our time, and this is the last session. I was hoping to do a little bit of talking about your experience in taking this course, but what I'll do is, and this is going to be really valuable to us as we sort of move forward and thinking about how to do this kind of professional development. I'll send out a survey tomorrow, because I haven't made it yet and I'm brain dead right now. But I'll send out a survey, and I'm going to follow up with you if I don't get one back from you. I will give you your money back, but I would please give me a survey, so because you're a small group, feedback you can get about both what you learned in this workshop, whether it was effective and you think it will influence your classroom teaching, but also how this kind of platform for delivering professional development worked for you. and what were the difficulties. So we've sort of dwindled down to the 4 people out of the original 10, but you know, that's 5. 1, 2. Yeah, so we have 5 of the original 10, so we're 50%. So I don't know if that's good or bad, but I would love to hear about your experiences with the technology. Was it easy to hear people when we broke up into a lot of that? How productive was that? And so I'll send something out on SurveyMonkey to you tomorrow, and I'll poke you if I don't hear back from you, and I'll make sure that the Moodle site gets updated with the videos of all the sessions as well as all the resources that we've used. And I want to thank you very much. This has been a great learning experience for us, learning how to try to figure out how to do this, and we will continue to explore it in the future, I am sure, and we will let you know in case you want to try this again. But also keep an eye out for face-to-face stuff that we do. We'll have a summer schedule of development, and Tanya couldn't make it to our PD over the last couple of weeks, but Toby was here. We had a great time, and it was fun to meet a whole person instead of just like a little floating head, and we had a good time. So anyway, thank you very much, everybody, for being DPIGs on this one for us, and we'll definitely be in touch. All right. Thanks a lot. I'll stick around a little bit if somebody wants to join with me and have any comments. So cheers. Bye, everybody.